I'm Nick Whetstone.
And I'm Kane Rodriguez.
And this is our submission to the Design Automation Conference Internet of Things contest.
For our submission, we decided to make a people counter using the ICE40 HX1K FPGAs and Raspberry Pis.
And now we are going to show a short demo of our system in use.
Now, with the person exiting the room, you can see that it registered that there's a drop in one person in the room. Now, with the person walking back in, the system detects the event and logs back to the screen. Now with another person walking into the room, the system again detects the event and shows it to the user on the screen. And with a third person walking into the room, again, system detects the event. And now we're going to explain to you a high-level explanation of how our system operates.
So our system uses a TX node and an RX node, and they communicate using an infrared signal. And once the stream of infrared signals is broken, an event is triggered that is then processed by the server to determine whether it was an entrance or an exit to the room.
This entrance or exit event is then sent to the client, which can access the server through a locally hosted Wi-Fi network. As you can see, this is a user's phone who's able to access the network. And they're able to trigger and view people walking into the room and, actually doing it this time, exiting the room. Our design has a very easy user setup. All you must do is first download our source files at the link below. Then you need to have an 8 gigabit micro SD card or higher. And what you can do is you can, inside the source files, you will find the image files for the SD cards. There are two different image files, one for RX and one for TX. For the RX, once you flash that using a Win32 disk imager program, you can insert it, the SD card, into the Raspberry Pi, as seen here. And that's for the TX, and for the RX, you can put it on the RX. After those steps, you will then use the source code provided to download the bit streams to the FPGAs. To do that, you need Diamond Programmer, given the link below. Once you download the Diamond Programmer, you'll be able to download the bit streams to these FPGAs. And once this is configured, you'll be able to set up the hardware. You have on the top left port the TX that will be on the inside of the room, and on the bottom port, seen here through an extension cord, you have the TX for the outside of the room. The RX FPGAs operate in much the same manner. After these two are set up, you will then be able to test your system. So first, you plug in the power source to your Raspberry Pi TX node first. Once you see that the LEDs are showing a different pattern than the default pattern, you may then plug in the RX node Raspberry Pi 3. Keep in mind that right now these are hooked up to the wall, but it's recommended that you use a portable power source, so you may attach it to a door in the future. After that is done, you go to a mobile phone or a laptop or a desktop. You search for the Wi-Fi network. Here, the network is named MTAV. You type in the password. Password by default is 1, 2, 3, 4, 5, 6, 7, 8. You may get a pop-up that says limited connectivity to the internet. That is okay. Click OK. Go back. You go to a modern browser like Chrome. You type in any URL and you'll be routed to the page hosted on the RX node.